Hello, this is Keenan Park, and this is YLOC 7th grade worksheet lesson 10. For our first question, we're going to find the area of this kitchen floor given its width and its length. So the formula for area, presumably this is a rectangle given that we're width and length. So we're going to be multiplying the width and length. The formula for the area of a rectangle is you multiply the side of this side length, which is the width, and this side length, which is the length, and you multiply them to find the area. So we do 2.30 times 30.1. If you multiply that out, you should get 7.13. And so you'll notice that it's not 71.3, even though the dots seem like they'll go here. They actually go over here because there's we move over one decimal point here, and we move over one here, which means we have to add 1 and 1 to get 2 points moved over. And if it was 71.3, that'd be kind of weird, because 2.3 times 3.1, that should be, well, definitely not in the 70s. So you should clue in that might not be right, and see that 7.13 makes more sense. So that's our answer. Next, we want to find which expression is equivalent, and we're going to do this by distributing this multiplication. So this 0.2 will go to both of these terms. So when you distribute, it goes to both of the terms. So what's 0.2 times x? That's just 0.2x. And what's 0.2 times 1.3? You can try multiplying that out, but I can just do it in my head. It's 0.26. So we get our answer is B. Next up, we're finding the area again of a phone this time, which is definitely a rectangle. So we do 4.2 times 7.6. Let's multiply that out. And then when you add them together, remember to move the decimal point over 2 spaces because there's 1 and 1, so that's 2. So it's 31.92. And your units should be centimeters squared. This is because we're multiplying centimeters by centimeters, so we have centimeters times centimeters. Anything times itself is the same as something squared. So this is centimeters squared. So units of area will be in a unit of length squared. So it could be inches squared, it could be meters squared, it could be any unit of length squared. Next, we have John buying 1.6 kilograms of sugar at this price of $2.4 per kilogram. So once again, we'll multiply these two numbers. And then when you multiply these numbers out, you'll find you have 384, but then you need to add the decimal point in, so 3.84. So it's B. Next, Anahi rides her bicycle at a constant speed of 4.2 miles per hour. And how many miles will she pass in 2.5 hours? Once again, we just multiply. So you'll end up with 10.5. So that gives us option D. And then we do 5.2 yards. And now we have to estimate the height of the house. And we know that 1 yard is about 0.9 meters. So once again, to convert, you'll multiply 5.2 times the approximate conversion, which is 0.9. And so we get 4.68. But none of these answer choices are 4.68. But since we're just approximating, we could just try rounding this up. And if we round this, we look here. Well, the 8 is greater than or equal to 5. So we will end up increasing the 6 to 4.7, which is B. And then the length of a pencil is 7.5 inches. And so we want to find the best estimate of length in centimeters. So to solve this, we are once again converting. So we have to multiply 7.5 by 2.5 because they're 2.5 centimeters per inch, and we have 7.5 inches. And then when you do this multiplication, you will get that this should be a 7. You'll get 18.75 which is conveniently right here as an answer choice. It's answer C. And now we're going to be doing these equations. We're solving them for x. So we're going to find the value of x. So to solve equations like these are all relatively simple equations. So the steps to solve them will always be pretty similar. We're always going to try to isolate the variable, keep it on one side, or we want to move the variable to one side and isolate it, and that way we can find the value of the variable. So we have 2x equals 4x minus 18. We want to have the x be on one side. So since 2x is smaller than 4x, I'll subtract 2x from both sides. You could also subtract 4x, but then you'll end up with negative numbers, and that's not quite as nice. So 2x minus 2x is 0, and then 4x minus 2x is 2x, and then we still have minus 18. Now we have 0 equals 2x minus 18. To move the 18 away from the 2x, I'll add 18 to both sides. That'll give us 18 equals 2x, and then to get rid of this 2, I divide both sides by 2. That gives us 9 equals x. So the value of x is 9. I'll skip over, actually no, I'll do number 2. It's a similar problem. We subtract 6x from both sides because that's a smaller one and probably will be easier. Then we end up with 3x plus 15 is equal to 18. And we subtract 15 from both sides. When you subtract 15 from both sides, you end up with 3x. 15 minus 15 is 0. And so you just get equals 18 minus 15 is 3. And then when you divide both sides by 3, you get x equals 1. Now for I'll skip number 3 since it's very simple and go to number 4. So in this case, we want to isolate the x squared again, but you'll notice it's x squared, so that's a little bit trickier. But once again, we'll just start by isolating it by adding 15 to both sides. So we end up with x squared minus 15 plus 15, that's 0, equals 25. And so we take the square root of both sides, but when you take the square root, you have to add a plus or minus. And that's because if you multiply a negative number by itself, like negative 1, and we multiply that by negative 1, then you'll end up with positive 1. But if you multiply a positive number by itself, like 1 times 1, you also get 1. So when you take the square root, both of these could turn into either negative or positive version. So when you add the square root, you have to put plus or minus. If the square root is already there, we assume that that's just a positive one. But in this case, since we're doing the square rooting, this x could be positive or negative, and we wouldn't know when it turns to 25. So the square root of 25 is 5. So x equals plus or minus 5. And you'll see if we plug in 5 to x squared, 5 times 5 is 25, so that lines up. But if you plug in negative 5, and we multiply those, that also equals 25. So it shows that both positive and negative 5 are valid answers to this problem. Alright, it looks like that was the only one with the next square term. So that should have been probably the hardest one out of this set. I'll just do maybe a couple more problems, but these all look relatively simple. This one looks like the most complex, so I'll do that. So x minus 16 equals 2x plus 14. I'll subtract x from both sides as usual. Doing the smaller one tends to be easier. So we end up with negative 16 equals just x, 1x, plus 14. And now I'm going to subtract negative 14 from both sides. So you get negative 16 minus 14. When you subtract a number from a negative number, it'll become even more negative. So we have negative 30 equals x. So x equals negative 30. And you might think that's kind of weird for the answer to be a negative number, but no, it's perfectly fine. That's just the answer. If you want, you can try plugging it in to check. So all of these, you can check by plugging them in. So if we do negative 30, and we plug that in to x, we'll get negative 30 minus 16. And now when you plug things in, it's nice to put parentheses so you don't accidentally miss a step. Equals 2 times negative 30 plus 14. So negative 30 minus 16, that's negative 46. Negative 2, or 2 times negative 30 is negative 60, plus 14. And then this right side turns out to just be negative 46. So negative 46 equals negative 46, which is correct, which means that our assumption we made, negative 30, turns out to be true. That's all for today's video, and thank you for listening.